This video is for Math 109, the health students, and it is practice on percent solutions because I can see that some of you are having some difficulty with this. I'm hoping that this exercise might help you understand it a little bit better. When you're dealing with solutions, percent solutions, what you need to remember is that if you have something that is, say, a 5%, let's see here if I can get this to work, 5% solution. What you need to know that means is that you have 5 grams over 100 milliliters. Now, the grams represents a solid. Remember, G is grams, which is mass or weight in the metric system. So this is kind of like a salt and water mixture. Salt would be the grams, and then it's dissolved into 100 milliliters of solution, or in this case it'd be water or whatever else it might be dissolved into. So percent solution is always listed as gram over milliliter. If your units are not in gram over milliliter, you have to change them and then just reduce the fraction, change it to a decimal or a percent, and you're done. For example, let's look at number 2 because that's a little bit easier than doing number 1. A 1 liter solution contains 9 grams of sodium chloride. What is the strength of the solution expressed as a ratio in percent? Okay, you have a 1 liter solution with 9 grams. So remember, our percent, we have to find the percent solution. Well, we're given 9 grams over 1 liter, but percent solution has to be in grams over milliliter. So our grams is okay here, but we have liter. So let's change that liter to milliliter using dimensional analysis. So you can go this way with dimensional analysis, remember. So I would put liter here, and I want milliliter here, because then I have it in the right form to know what my percent solution is. Well, think about our Kiss Hairy dogs, but drink chocolate milk. A liter to a milliliter, which one's bigger? The liter, so you put a 1 there, if my little board starts working. And then how many milliliters are in a liter? Because it's 3 over, there are 1,000. We talked about this in class, 1,000. So if we multiply across, notice your liters cancel out, we get 9 grams over 1,000 milliliters. And that now is in the correct format for percent solution because we have gram over milliliter. And now all you do is divide out the fraction. 9 divided by 1,000 would give you 0.009. But we need a percent solution. So we change this to a percent by going right to, and we end up with 0.9%. So that is your answer. That is the strength of the solution. It is a 0.9% solution. How do you express that as a ratio? Well, that would be a fraction form. That would be this right here, this format here, the 9 grams over, my pen is not working, 9 grams over the 1,000 milliliters. Okay, let's try another one that's a little bit harder. And again, it uses dimensional analysis. That's why we learn dimensional analysis. Look at number 1. There are 2,250 milligrams of sodium chloride in 1 liter. So we have 2,250 milligrams in 1 liter. Always put your solid, which is milligrams, because grams is weight, over your liquid, which is 1 liter. Because those are the problems we work with. When you get into your nursing classes, they will do different milliliter over milliliter. But right now, all we're going to show you is your grams over milliliters. Okay, so we're going to start here with 2,250 milligrams. We need that to be in grams. So right away, let's change that. Okay, so I'm going to put milligrams here because they have to match, and I want it to be in grams because I need my grams over milliliters. So which one's bigger, the grams or the milligram? The grams is bigger, so that gets a 1. How many milligrams are in a gram? Remember, they're 3 apart, so that's 3 zeros, 1,000. And then if we worked this problem out, we would be left with grams over liters. We have the grams, but we don't have the milliliters. So I'm going to do another dimensional analysis to change this 1 liter to milliliters. So I would have to put liter here because it has to be across from this, and milliliter here. Which one's bigger? Liter gets a 1. It's how many away from the milliliter? 3. 3 spaces would be 3 zeros. 1, 2, 3. Now your liters cancel, and notice what units we're left with. Gram over milliliter, and that's what we need, gram over milliliter for percent solution. So let's multiply across. 2,250 times 1 is 2,250 grams over 1 times 1,000 times 1,000 is going to give you 1,000,000 milliliters. And if you divide that out by decimal, you're going to get 0.00225. And to change that to a percent, we go to the right 2, and so your answer becomes 0.225%. Again, that's 0.225% because we had to go right 2. So hopefully this will help you get a little bit of an understanding of, a better understanding of percent solution. Let's look at number 3. If 5 grams of pure drug, are added to a container of sterile water, and the total volume of the solution is 50 milliliters, what would be the strength of the solution expressed as a ratio in a percent? Again, strength of the solution, gram over milliliter. So we're given 5 grams over 50 milliliter. Now, notice we have everything we need. It's in grams over milliliters. That's exactly what percent solution has to be in. So all we have to do is reduce the 5 over 50, which just gives us in decimal form, or in fraction form, 1/10 gram over milliliter, which equals 0.1. And that, as a percent, equals, go to the right 2, so you get 10%. That's our solution. It's a 10% solution because there are 5 grams in 50 milliliters. 5 grams of pure drug in 50 milliliters of solution. So this is our percent solution. That was an easier one, isn't it? If they could only all be that way, right? Number 4. Let's see how we do with number 4. Determine the number of grams of calcium chloride contained in 50 milliliters of a 10% calcium chloride solution. Determine the number of grams. Okay, so we have a 50 milliliter solution. So we have 50 milliliters over 1. That's how we're going to start this problem, because this one's a little bit different. This time we're given the percent solution. Notice that? And we have to find the grams. Before we were given the grams and the milliliters. Now we have to find the grams. So we start with what we're given, which is 50 milliliters, and we're going to multiply it by, of course, milliliters would have to be here, and then we want grams here. It's a 10% solution, so we know that that automatically tells us that is 10 grams over 100 milliliters, because that's what percent solution means. You know percent means over 100, so it's always going to equal that. So we have 10 grams over 100 milliliters. Cross out your milliliters, which is what we wanted because we were trying to find grams, and we get 500 grams over 100, which equals 5 grams. So in a 10% solution, if you have 50 milliliters of your solution, you would need 5 grams of your pure drug. And you can see that's the opposite of the one we just did. It's the same exact problem, but we just came at it from different angles. The point is trying to understand what percent solution means and what you're given. let's see if 5 is any better. Determine the number of grams, so we're going to do it like this one, of mannitol contained in a 400 milliliter solution of 25% strength. So we have 400 milliliters. Remember, in dimensional analysis, list what's given first. And we're going to find the number of grams by using our percent solution. Well, 25% solution, we know right away that's 25 grams over 100 milliliters, because that's the definition of percent solution. So milliliters here, grams here, we have 25 over 100, which equals, notice our milliliters cancel, we're left with grams, which is what we wanted. So 400 times 25 gives us, let's see here, 400 times 25, and I don't have that exactly worked out, so let's figure out real quick what that is. 10,000 over 100, which equals 100. Cross off your end zeros. 100 grams. So in a 25% strength solution of where you have a 400 milliliter solution, you would need then 100 grams to go with the 400. And that should kind of make sense. 100 grams to 400 is 1/4, which is 25%. See how it kind of all works together once you understand it? Okay, let's try another one. We have time for one more, number 6. How many milligrams of pure drug are contained in 30 milliliters? So we have 30 milliliters over 1. We know our 0.5 solution is going to give us what? 0.5 grams over 100 milliliters. So we multiply this by our milliliters and our grams. We have 100. Here we have 0.5. And 1/2 of 30 is going to give you 15 grams over 100, which is going to give you 0.15 grams. So you would need this many grams in 30 milliliters to have a 0.5% solution. Okay, so I'm going to stop the video, and I'll continue with a few more to help you if you'd like, and hopefully this is clearing things up just a little bit.